All right, guys, this is part 2 of the video that I'm making. All right, so we're going to go over the last few problems, number 15, 17, and 19, and then you guys can keep on studying for your test and finish those other problems. All right, for number 15, let's do number 15. All right, so number 15 says calculate the percent composition of potassium permanganate. All right, so here I'm being nice and I'm giving you again the formula, so let's write that down. It's KMNO4. KMNO4, okay? Now the answer is already here. We're going to figure out how to get here. So this problem is actually really easy. We just have to figure out how heavy KMNO4 is. We have to figure out the molar mass. And then after that, it's pretty straightforward. All right, so we need to figure out how much does K weigh, how much does Mn weigh, and then how much does oxygen weigh. So we're going to look at our periodic table. All right. You're going to look at, I already have one here, so I'm going to do that just to be quick, a little more quick about it. Once you do, you find out that potassium weighs 39, Mn weighs 55, and then oxygen weighs 16. You'll notice I'm just rounding up or down. I'm just kind of keep it as simple as possible. Okay. And then, sorry, oxygen, notice that there's 4 of them, so really this 16, don't forget we have to multiply this by 4, and that gives me, I believe it gives me 64, but I'll double check. Yeah, 64. All right, but really what we want to do is we want to add all this up to get the molar mass, so add this up. I'm going to get, all right, so 64, go to your calculator, 64 plus 55 plus 39 gives me a total of 158 grams total. Okay, now comes the easy part. You're just going to do, you want to find out the percent for each of these. So really you're just doing, there's only 3 elements, so you're just going to do this 3 times 158, the total. 158, 158. All right, and then you're going to do 1 for K, 1 for Mn, and then 1 for oxygen. So let's see what percentage, right? So out of a total, right, if you have 70 out of 100, that's 70%. So we're going to do 39 out of 158 and find out what the percent of that is. So we're going to do 39. We said Mn was 55, and then we said oxygen is 16, but there's 4 of them, so we're going to add that all by 64. So let's see what we get. So in the calculator, 39 divided by 158, we get point, I'll write this down here, 0.24, but remember, we don't want this in decimal, we want it in percentage form, so we have to multiply this by 100, and then we get 24.6. Sorry, 24.6%. We'll do the same thing here. I'll go back to my calculator. 55 divided by 158. I get 0.34, but again, we don't want decimal, we want percent. So multiply this by 100. You're going to get 34.8%. And then the last one, 64 divided by 158, you get the answer is 0.405. I want this in percentage form, so that's going to be 40.5%, and you are basically done. If you look at the answers that it says next to it, you'll notice that it's the exact same numbers minus the first one, 24.6, which was actually, let's scroll up. I didn't round up like I should have, 24.68. There should have been an 8 there, which would have made this really into a 7. So small, minor error, but it is important nonetheless. All right, so that's how you do number 15. All right, we're going to go to the last 2 things, which is empirical formula and molecular formula. And that'll be the end of part 2. And then you guys can hopefully keep on studying, work on some practice problems, um, or hopefully you just understand the material by now that you don't have to keep on going. All right, let's go to number 15. All right, so when you're finding empirical formula, that's really the most difficult one. Molecular, I feel like, is really easy. It doesn't take that long to learn. It's not very hard. So let's cover the hard one first, and then we'll go to molecular, which will be the harder one, but still not too crazy. All right. Number 15 says, no, sorry, number 17. Determine the empirical formula for a compound that is, let's write that down, 40.0% calcium, 12% carbon, and 48% oxygen. All right. So remember, for these, we want to treat these percentages, we want to treat them like grams. So really, we have 40 grams of calcium. Really, we have 12 grams of carbon. And really, we have 48 grams of oxygen. All right. So you'll want to do them individually. So we'll start with calcium. All right. So we want to put that 40 grams. And we just want to figure out the we want to convert this to mole and then figure that out. So we already know that if we have grams, we need to use our molar mass. We're going to have grams at the bottom, mole at the top. 1 mole is always the case. And then here is just the added weight for calcium. In this case, there's only just 1. So we can look at our periodic table. Calcium over here, we notice that it's 40.078. I'm just going to go, well, let me go ahead and actually do it. 40.078. And that will give me a value. We'll come back to that in just a second. All right. Now we're going to do it for carbon. Carbon, it says I have 12 grams. I want it in moles. So again, grams to mole. This is always 1. Added weight. Carbon in the periodic table says it is 12.011. And we'll get an answer there too. And then for the last one, we have oxygen. It says we have 40, no, it says we have 48 grams. And again, we want this in mole. So we'll just multiply it again. All right, so 1 mole, we got 48 grams. We know that oxygen weighs a total of 15.99. Okay, now if you remember the rules, I'm going to make this a little bigger now. To get empirical formula, we want to divide, I'm getting a little ahead of myself, by the smallest number, but let's get our values first. So we have, let me get this before we actually move on. Let's put this in the calculator and see what we get. All right, for the first one, we got 40 divided by 40.078. That gives me 0.998. I'll stop there. Then we got carbon, we got 12 divided by 12.011. That gives me a similar number, not exactly the same. Won't matter too much, but just notice that 0.999. Okay, and then we have 48 divided by 15.999. All right, something to know with this, the numbers are never going to be perfect, but that doesn't matter too much. And I'll talk about, you want to round up to whatever it's closest to. Right, so 3.00. As long as it's within this range, that's good. If you had something like 3.5, then remember you have to multiply this by whatever number until you get a whole number. This isn't one of those, but I'll talk about that a little bit more in a second. All right, so let's look at this. Okay, so we've got our numbers. We want to, once we get these values, we're going to want to divide all of these by the smallest number. In this case, the smallest number is 0.998. It's only 0.001 smaller, but it's still the smallest one. So we'll divide all three by that value. And if you'll notice, honestly, this number 0.99 is really close to the number 1. We could have said 1 and then 1 divided by 1, it would have still been 1. 0.999 divided by 0.998, if you intuitively know what that is, good. But if not, if you're unsure, just put it in the calculator. 0.999 divided by 0.998, you get you get 1.000 blah blah blah, but it doesn't matter because it's close enough where we can just say it's 1. So when it's that close to the number, you don't have to multiply the number by anything. It's just going to be 1. And then you have 3 divided by 0.998. Again, 0.998 is really close to 1, so our answer is going to be, it's like saying 3 divided by 1, right? Our answer is going to be 3.006, which is really just saying this is really just 3. All right? So now what do these values actually mean? Well, that's what's easier. These values are telling you exactly what goes in front of your problem that we did at the beginning. So right here, where we have number 17, where we have calcium, C and O, where we have calcium, C, and O, it's telling me I have 1 calcium, so I can leave it like that. It's telling me I have 1 carbon, so I can leave it like that. And then oxygen, it's telling me I have 3. So the only thing I have to do really is just go here and then just put a 3, and I have my answer. And if I look here, calcium carbonate, CO3, and I'm done. Okay? Now, I'm going to pretend for a second this wasn't exactly the numbers I got. Let's say, and this is just pretend, let's say this would have been something like, let's say I didn't get 3. Let's say I got 2.99. This is still really, really close to where I can say that actual number is 3. If it would have been something like 2.5, this isn't close enough where I can be like, okay, this is 3 and 2 for sure. So I have to multiply this 2.5 by something to make it whole. In this case, I would have to multiply 2.5 by 2 to make this a whole number, the whole number being 5. If I multiply this by 2, I've got to multiply these by 2. And then I wouldn't have had CaCO3. I would have had Ca, there's 2 of them now, carbon, there's 2, and then oxygen, there would have been not 3, but there would have been 5. Okay? So you can kind of work that out as you need to. I'll give you one more example, but if you got something like 2.3 and you tried multiplying by 2, that gives you an answer of 4.6. This is still not close enough where you can say this is a whole number, so you would have need to kept, so that number 2 wouldn't have worked, so you would have tried something else. How about 2.3 times 3? That would have given you 6.9. This is close enough where you can be like 6.9 is really just the same as 7. And this would have been your number, and you would have multiplied these numbers up here by 3 as well. Okay, so just keep that in mind. I think for the test, we'll try to keep it easy so it's not too hard, but in case you come across that problem, I wanted you guys to be prepared. All right, last one, we got the really easy one. This is one of the most processed. This particular one we just did is one of the most painstaking ones, but this next one I think should be really easy. And this is the last bit that you'll see on your test as well. So this is about the last 30% of what you're going to see on your test. Sorry, it just takes a little time to erase this. All right, so let's go to the last one, number 19. Determine the molecular formula of an unknown compound with an empirical formula of C5H2. So that's good. We got that this is C5H10, and then oxygen is 2, okay? Molecular formula, and then it tells us the molar mass. Okay, so it tells us that our molar mass is 204.30 grams, I believe, 30 grams. Let me actually move this a little bit to the right now. I'll actually rewrite that. All right, so we got C5H10O2, 204.30 grams per mole. All right, determine the molecular formula for the unknown compound with an empirical formula and a molar mass of. So what this is saying, the molecular formula of an unknown compound. Okay, so we know that we have this compound, but we know that this isn't exactly right. We know that the compound at the end, at the very end, weighs 204.30. Okay, I know that this compound right here, I don't know the weight, so I have to figure out the molar mass. Okay, so this is 204 is for my X. I don't know what it is, grams per mole. And this one, I don't know what the gram is, but I know that this is for this particular formula right here, C5H10O2. Let me expand this a little bit. O2. Okay, so 204.3 grams. I don't know what compound this belongs to. That's why it's X. I know that this is my compound for the bottom, but I don't know what the molar mass is. So I have to figure out the molar mass. That's easy to do. I just need my periodic table to do that. So I'm going to scroll down a little bit. So we've got C5H10O2. I just have to add everything up, figure out how much it weighs. So let's just do that. So we've got 5 carbons. I know that carbon weighs 12 because I found it here. Plus hydrogen, I know weighs 1, but there's 10 of them. Plus oxygen, I know weighs 16, but there's 2 of them. And when I add everything up, let's see what I get. I get 5 times 12 plus 10 plus 16 times 2. I get that my number is 102 grams. All right, so now I know I can put this number here, 102. So basically we have 204.3 divided by 102. So let's do that in the calculator. 204 divided by 102 gives me the number 2. Right? And once I get this number, I'm going to multiply what I originally had. I originally had C5H10O2. But this number is basically saying that whatever compound, whatever X is, this is twice as heavy. So it's 2X, right? So all I need to do now is multiply this whole thing by 2 to figure out what X actually is. In this case, so carbon, there's really 10 of them. H, it's really 20 of them, and oxygen is 4 of them. Okay? And if you look closely to our numbers, what are we saying? We know that the end result was 204, and when we added this up, we saw that it was 102. So we can see, without even doing the math, that it is double. So we got C5H10, 2, 102. This number tells us it's double, or 2 times as much, so our end compound has to be twice as much. So it would be C10H20 and O4. I think this is one of the easiest you're always going to do. Just to kind of summarize that one, you're always going to do your molar mass for the one I give you, your given molar mass, and then, I'm sorry, your molar mass for the given and then you're going to divide that by your molar mass that's not given to you, that you have to figure out yourself. And then you'll just multiply by whatever you got. All right, that concludes part 2 of the video. Good luck on your test, and hopefully this helped.